recently we've had an incident. The crypto world loses almost 50 million in DeFi swap, and so this was an incident where crypto world lost nearly $50 million after attempting to swap 50 million in AETH USDT for AETH Aave through Aave's swap interface powered by DEX aggregator COW protocol. And what does COW do? So COW is a coincidence of one protocol. And we'll look in the intricacies of what DEX is and what these all stand for. So for context, yes, we are going to be looking at that. I would encourage us to really read deeper on smart contracts in learnweb3.io. There is a Solidity, there is I think an Ethereum degree, there is Solidity by example. This is a good place to read through, but today we are going also to ascertain what decentralized exchanges are and why they are so important. So let's get started. What's a DEX in full? A DEX is a decentralized exchange. And let's dive on how this came about. So these are essentially called AMMs. So they are called AMMs, and this is automated market maker. Automated market maker. Sorry for that. So and so with these automated market makers are simply automatic ways of regulating a decentralized market. And as you know, most of us are used to buying crypto through centralized exchanges, exchanges like Binance, Coinbase, and others. So oftentimes we resolve to the same platforms when trading between different cryptocurrencies. However, centralized exchanges are rife with problems. They can get hacked and lose all their users' money, or worse yet, the company behind the exchange can close up shop and run away with all the money. So there are some of the issues with the centralized exchanges. Since they are centralized, in case a centralized entity, maybe the government is coming for you, they can freeze your accounts, but they could also close and then you have nowhere to go to. So things like some of the examples of centralized exchanges include platforms like Binance, Coinbase, and so on. So we are most of the people in the crypto sector are used to buying, selling, and carrying trade through these centralized exchanges. And you don't have full autonomy over your assets on such platforms. So examples like we saw in 2014, Mt. Gox was the leading Bitcoin exchange, I think from 2010 to 2014. At its peak, it was responsible for 70% of all Bitcoin transactions. And in early 2014, the company reported they were missing hundreds of thousands of Bitcoin and declared bankruptcy. And today, those lost Bitcoins are worth billions of dollars. So we have other centralized exchanges that had issues. We had Quadriga CX. So we had okay, let me see if I can get something that is easy. Okay, so I will just All right. Um, Centralized exchanges. So some of the examples that were very sound back then, that closed, include the famous MT, Gox. We had Quadriga, CX. Quadriga CX, that went out under 2018. So the founder mysteriously died and all crypto of the platform disappeared with him. Users reported almost $200 million in lost funds. So we had all those issues, and this is what led to the birth of decentralized exchanges. So the idea of a decentralized exchange is simple: allow users to trade their crypto directly on chain through smart contracts without giving up control of their private keys. And that's a very powerful thing. If you can trade your crypto, without a middleman, and you are not giving out anything, maybe not giving out your keys, not giving up your sovereignty. So centralized exchanges. Okay, so that's the idea behind them. And we are going to really come up with how these smart contracts are built, the logic behind. So while it sounds simple, the reality is much more complicated. In reality, these are pieces of mathematics software combined together to form something that market makers, liquidity providers, and users can come in and interact in a decentralized manner while just trusting mathematics. And that was what led to the birth of modern decentralized exchanges like Uniswap. So one of the things that we know about Uniswap is people think it is just the leading decentralized exchange on Ethereum, but actually it's also the leading app in general on the Ethereum ecosystem. And this came out after Vitalik's post in 2017, when Hayden Adams, was inspired to try to implement it. So let's look at detail. What's the problem? What's the real issue? Okay, I think I'll use this for a while. It's a good. You might be wondering, why can't we? Why can't we just recreate a centralized exchange on chain? Please mute on chain. Well, just creating a centralized exchange is not good enough, and one of the things that actually centralized exchanges work on is an order book. So if you want to know what an order book is, an order book is simply when one entity says, I'm buying amount of this token. Order book, centralized exchanges. An order book is where somebody puts up an order saying that I'm buying this amount of tokens for this amount of cash. And this is how centralized exchanges operate. So there are really very many solutions also in this direction. And some of the centralized exchanges like Binance use this order book. So centralized exchanges typically work on order book system. Alice puts up a listing saying she's willing to sell 100 tokens of A for 50 tokens of B, and the listing is added to the order book. At some point, if Bob comes along and says he wants to buy 100 of token A for 50 of B, their orders are matched together and the trade is executed. So order book based exchanges were attempted on Ethereum, with the most significant example being OX project. Yes. So remember the days, I think it was 2021 when OX was implemented, but was very cash consuming and a bit more slow. So, but due to the high gas required for all the storage and matching algorithms, it was challenging to attract users. So some of the order book protocols include Orderly Protocol. I think Orderly Protocol has been one of the order book exchanges that has survived some good amount of survived time, and yeah, it's a protocol built on order book. So we have solutions like Hostfy on it, and yeah, you can research about it. So total of 106 access points. TVL is about 18 million. Yeah, you can research about the Orderly protocol. It was really a good implementation of the order book. Yeah, the order book system. So as we continue, that's how Uniswap came about, and Uniswap started with Uniswap v1. Okay, I think I can go back. So we started with Uniswap v1, Uniswap v2, Uniswap v3, and now we are having Uniswap v4 with hooks. So yeah, here I think order book. High gas due to storage. Yeah, and this is how we came up with the Uniswap protocol. So the first version of Uniswap, which we are going to concentrate on today, was launched in November 2018 and allowed swaps between ETH and an ERC20 token. Chain swaps were also possible to allow for token-to-token swaps, such as going from token A to token B. So by first covering one of them to ETH, then ETH to buy another token. So the way this worked was you had the ETH token in the middle. So if you wanted to move from, you could move from ETH. Oh, this is now Chinese. ETH, you could move to another token, let's say token A in this first version, and then if you wanted to move, for example, from token A, okay, I think better to copy and paste. So if you wanted to move from token A to another token, let's say token B, you had to move from A to ETH, and then from ETH to token B. So this was the early version of Uniswap, but there is a lot that actually was carried on to other versions. So then when Uniswap v2 came out in March, I think that was 2020, was a huge improvement of v1 that allowed direct swaps between ERC20s. So Uniswap v2 just made an improvement on this. Where if you wanted to move from token A to token B, you could actually move directly without going through ETH first. So you could move from token A just directly to token B, and that was a very huge improvement. Sorry about everything. Yeah. And then we had then the Uniswap V3 come out. I think that was May 2021, and improved on capital efficiency, which allowed liquidity providers to remove bigger portions of their liquidity from pools and still keep getting the same rewards. Then Uniswap V4 came out in June 2023 and allowed for custom hooks to be added to pools and also singleton Uniswap. So with V3, with V2 we had, hopefully this thing will draw well. I really have to learn a lot here, but yeah, let me use what I can use. And okay, so in V2 we had like liquidity moving in this pattern, where it was a continuous flow of liquidity from if we had token X and Y, and in V3 what we did is to make sure that we have these curves in given intervals. So in V3 what was happening is we are going to explain it further, but what usually happened was that now you could have, let me say, given intervals where this motion could happen. So you had finite liquidity provision, whereby this same curve, maybe that it moves over that interval and another one moves over that interval. And if you had another interval, let's say here, maybe you have another liquidity provision. We are going to see this in detail, but it's V3 was simply an extrapolation and increasing efficiency of V2, and V4 then came along with hooks and singleton architecture, whereby you didn't have to lose gas every time you are making an exchange between given tokens that are not of the same like that are not in the same pool. So yeah, but we are going to be seeing most of these in detail. So what are market makers? Uniswap is an automated market maker, and if I'm to break down a market maker, market makers are entities that provide liquidity or assets to trading markets. In non-order book systems, liquidity is what allows trading to be possible. That means if you want to sell BTC to buy ETH, the exchange must have an ETH balance you can purchase from in exchange for BTC. Some trading pairs have very high liquidity, e.g. BTC, ETH USDC, but some have extremely low or no liquidity, like most of the meme coins that are newly launched. So a DEX must have enough liquidity to function and serve as an alternative to a centralized exchange. One way to get that liquidity is that developers or investors put in their own money and become market makers. However, this is not realistic, as they would need a huge amount of money to provide enough liquidity. Yeah, so essentially market making is simply making sure that we have enough liquidity in the pools. So one of the ways actually the prices come to be on Uniswap itself is through Uniswap X, where people come and keep buying and selling this token based on different circumstances and different markets. And then an average price that has been used is what is used on Uniswap, the platform. You see now, like here, selling just 500 USDC for 0.2 ETH. They will show you, find the best swap. Market makers are coming from all over, Balancer, Curve, some are MEV, to make sure that they create this market. So someone may be buying $500 for more, and as long as that swap is created, that's what creates the market. So Uniswap X is a place where people just come and exchange based on the orders that other entities have put. Like maybe I have $500, I need 0.2 ETH. Is there anyone? And then Uniswap X searches all the people behind the market, search everywhere on Balancer, on other exchanges, to see if they can get this trade done. And as they get more trades done, the average of the trades is what accounts for the price that we see on the Uniswap exchange itself. So since now Uniswap the builders didn't really have that liquidity, what Uniswap did is to make sure that they opened the protocol for anyone to be a market maker, and this is what makes Uniswap an automated market maker. So if you have your tokens, you can be among the people who provide liquidity, and ultimately be part of the market makers. So any user can deposit funds to a specific trading pair and add liquidity, and in exchange earn money for doing so through the trading fees taken from the users. So functional requirements are considering what we have looked at. Anyone can add liquidity to become a liquidity provider. Liquidity providers can remove their liquidity and get back their crypto whenever they want. Users can swap between assets present in a trading pool, assuming there is enough liquidity. Users are charged a small fee, trading fee, that gets distributed among the liquidity providers so they can earn for their liquidity. And this small fee is also part of the fees that, if I look at pools, reposition. So also these are the part of the fees that are taken back to the protocol. Okay, can search for ETH USDT, search for pools, USDC with USDT, USDC. See, now this is one of the liquidity pool fees. Yeah, so this is very open to anyone who has liquidity to become a liquidity provider. And as we continue, we can know that maybe before we continue. Is it making sense? Or let me see. So if I connect my wallet, I can also provide liquidity. Actually, here there is add liquidity and swap. So when you add liquidity, you get 2.36% as your APR. Is it annual protocol reward? I don't know, but as your APR. So you look at this, and there is a total value locked is already $12 million. And so how did the Uniswap protocol come about? So Uniswap V1 was formed on a mathematical equation called x times y equals to a constant k. So this is at the core of Uniswap V1, is this equation, and this actually is where most of the improvements were built on. So we can go through a working example. So where X is the balance, an example could be we can have X as maybe the balance of ETH in a trading pool, and Y as the balance of a given token, of a token in the same pool. This could be a pool of ETH, maybe USDC, something like that. So we have X and Y, and K is a constant value. So K is a constant value. So from this equation, Uniswap derived most of what is being built on in the Uniswap protocols. So yeah, even if X or Y represents the other token, doesn't matter. So assume you are swapping your ETH for the token, thereby you are increasing ETH in the pool and decreasing token in the pool. So when you have a scenario where Control copy and Control V, if I take scenario, a scenario for swapping ETH for the token, that means that if I want to get I have my ETH, I want to get more of the token, so I'll have to a scenario for swapping ETH for the token or token for ETH. That means that the token that I'm getting more of, I'll have to increase a certain amount. I can name it delta X, and just from the above equation, after swapping, I'll have one of the tokens increased times the other token decreased by a significant delta Y, being equivalent to K. So yeah, this is what happens when you're swapping. Essentially, whenever you are swapping, the token that you are swapping to will have increased, and the token that you are swapping from will have reduced. So since these are not the same tokens like one-to-one, the token that you are increasing will increase by a factor. We have called it delta X. And the token that you are decreasing will decrease by a factor. Let's call it delta Y. So fitting those in our first equation, and this equation was created by the Uniswap team, and that formed the basis of creating the decentralized exchange. If I give this as my equation 1, and this as my equation 2, as we have looked at it, we can find the amount of the added token or the removed token, delta X or delta Y, from both equations. So given given this from 1 and 2, if we want to find delta Y, so which is in this case probably the reduced amount of ETH dy from equation 1 being equaling it to equation 2 I have x times y equaling to x plus y, because k is the same as k, so I'll have these two being equal. And yeah, now from here we can expand and make sure that we put dy on one side. Maybe let's take it step at a time so that it is visible. X times y will equal to x times y, xy, or x times y. So I'm multiplying this x by this y, which will give me x times y, and then x times minus delta y, which will be minus x delta y, and then we have this delta x times y, so plus y delta x plus y delta x, and then we can also have delta x delta y. So that's one of the ways we can do it. But the other simpler way could be, since we have negative delta y this side, we divide both sides by x plus delta x. I think that's a simpler way, since we want to just find delta y. So we have divide both sides by dividing both sides by x plus delta x. So you will have y minus delta y will be equivalent to x times y over x plus delta x. Okay. So now here, if we want to have delta y, we take delta y this side and y remains on this end. So we shall have delta y will be equivalent to y minus, if I open these brackets, because I've crossed delta y and I've crossed x times y so if I can put angle brackets here so that we see it very well. Over x plus delta x, and yeah, so delta y will be equivalent to, so for us to have y with the same denominator of delta x, so this is like y over 1, so we have everything. If I'm write it here, I don't know if this will work. So it's like I'm having draw line here. This is becoming much. It's like I'm having the dy equaling to y minus xy over x plus dx. So if I want to have over x plus dx, I have to make a good practice with this. I have maybe I can say this y over 1 and say this is like y over 1 and say x divide by 1 this times y, so I will have y into x plus dx minus xy, because x plus dx divided by x plus dx, you get 1 times xy. So you'll find these equations helping you, whereby sometimes you have dy as the subject and sometimes you have oh god, I'm still learning this thing, but it will work out. And sometimes you have dx as the subject. So in our equation, dy was the amount of the token that was decreased or that was exchanged to get an amount of the other token in the pool. So that equation is the fundamental that grows into very many equations, some of which we shall see in even Uniswap, other Uniswap versions. And perhaps maybe we can try to, if you had to write this as code, you can try to write it and see how it will look. Remix. So as we are writing this, probably I can be giving an exercise. So I really want to use this space, but I don't know what to do. Okay. So the exercise is, my computer is starting to freeze. Assume we have 100 ETH. Oh god, this is a disaster. So assume we have 100 ETH. 100 ETH and 200 of token and 200 of token. In the trading pool, smart contracts. So what would happen if you wanted to swap 1 ETH for tokens? So if you wanted to swap 1 ETH for the token, so that will I would want to know how much of the token would have, how much that token we would get. I think, yeah, I think that's okay. Is that visible? Yeah. Oh, it's not visible. Hopefully it is visible. So you can calculate and probably put your answers in the chat. So assume you have 100 of ETH and 200 of token, and yeah. So you can base that on the equation that we have derived, on the equations, and perhaps get some answers. So we want to put these in code. So calculate output amount.sol. So why do I bring up these snippets? It's because as we grow in our code, we are going to see that in V4 we are going to be writing hooks, and hooks assumes that you actually know the entire architecture and where things are. So which is a very hectic thing. So if you really don't know, so I'm just going to give it a calculate output, just a name, so that I can have a place to put the function. So the way the function that calculates our output looks like is like this. So calculate output amount so you always have uint into 56 input amount. It's essentially having all these variables. So you have input amount, which was maybe y, you have the x amount in the reserve, so amount of in the reserve y, amount of the reserve x. Now the added input amount delta x, yes, so to get the amount delta y that was used. So putting that in sort of code, you go into 56 put reserve and uint output reserve. So you want to return Okay, yeah, let me just break this down a bit so that we can have view space. And this can be private pure returns. So you have to return a uint to 56. So essentially we are just going to get that sort of function and write it. So uint output amount of that token will be given to output reserve times the input amount and divide this by input reserve. Input reserve is the initial amount that was put in the token plus input amount. So as we go through protocols like Uniswap v2, you'll find that actually the protocol was a full implementation of this mathematical formula. So I guess from our exercise, assume we have 100 ETH and 200 of token in the pool. So what would one ETH that is being added to the pool, what would it be exchanged for in that same pool? So which answers have we got? So if you haven't gotten any answer yet, one of the answers I think you'll end up getting is 1.9801 of the other token. So 1.9801 something of the second token. You find out that with this formula, actually x times y equals k, you never get to a position 0 of the token. So you always have a curve that does not hit the 0, even when you try to remove all the tokens of a given other tokens. The curve, you will not reach a time when you have a 0-0-0 balance. That's why these automated market making mechanisms are a bit funny, that you should know how that market works. So in the instance of the gentleman who lost his money to the coincidence of one swap, it was because the market was made in a way that it will regulate itself never to run out of exchange, and that when you're moving such huge amounts of money, it can lead to a very high level of slippage, and there we are going to be looking at that as well. So if you had to look at So if you are looking that you remove, the curve is already does not reach the x-axis or the y-axis, meaning that there will always be some bit of tokens that are left in the pool after adding the initial liquidity of that pool. And that's the thing that causes slippage. So since we don't get tokens in the exact ratio of reserves, this leads to an interesting implication of the math. The price function causes slippage in the price. So the bigger the amount of token being traded relative to their reserve value, the lower the price would be. So in cases where you would want to drain the 200 ETH, you'll actually not drain it out because of the way the curve is created. So the other question could be who sets the initial price of the tokens? One of the things that we really don't look at so much is this theory, and it is something that should be highly appreciated because it will help you. It helps you in saving. It helps you knowing how best to use these decentralized exchange because they are automated. So we've talked about slippage, meaning this is a mechanism that is used to make sure that the market, does not trade all the tokens out. So now we are talking about for it. Therefore, the first person adding liquidity to the pool gets to set a price. Adding liquidity involves adding tokens from both sides of the trading pair. You can add liquidity for just one side. When the first person adds the liquidity, it queries the reserve balance and sets the initial X and Y values. From that point onward, we can do price calculations when swapping between tokens. So when someone adds liquidity, they automatically create the first prices, but those prices are brought back to maybe the market price based on things like liquidations, MEV, and with those aspects like the bots, the market will always resolve to what the token actually buys and sells on other different exchanges. So liquidation MEVs happen whereby if you can find a price of a token on a given swap being different from a price of a token on another swap. For example, let's say we are on ETH on this, and I want to swap let me say ETH 1000 ETH. I want to swap it for BNB. So let's say I want to swap 1000. So I might get 100 ETH to BNB. Oh, this is not good. So large price difference. 1 ETH is 0.1. Okay, let's take it like that. And when I go to another platform, let's say Pancake Swap. just starting to slow down a bit. So they want ETH, and to BNB. So with 100 ETH, I'm calculating. You can find that there is a small slight, here you get 0.16969. So for 1 ETH, you get 0.169 of BNB token. And on PancakeSwap, network Binance, let me see if we have ETH. And here you will find that for 100, let me call it 1. For 1 ETH, you'll be getting 3 BNB. So if somebody looks at this slippage, they can take advantage of it. Like price differences, they can take advantage of it and then do what they call the front run, whereby they swap ETH to BNB on PancakeSwap and then come and swap it here from BNB to ETH on the Uniswap. So all these are possible because these are all decentralized exchanges. Literally no one is managing them apart from the liquidity providers that are set, and that's actually how these exchanges are kept in check. It is the users that come and swap these tokens that keep each other in check. So there are other implementations of functions like the add liquidity function. So we are going to just have simple implementations of them. So whenever you are adding liquidity, of course you have you'll be given the opportunity to put the place of the token, put the amount that you are adding, so that the amount that is getting out is calculated. So whenever you are adding any amount of token to a function, that function should be payable. Since we are adding liquidity and we want this to receive tokens, so we make the function payable. So if you are adding liquidity of any token, we can use the ERC20 interface to get the token standard, to make sure that it's an ERC20. and then we have token.transfer. Transfer from. So we saw that one of the methods that make a token ERC20 is the transfer from method, and it takes in three variables: the address of the sender, so in this case we call it message.sender, the address where that money is going to, so it will be going into this smart contract, and we use address this to say that actually this amount is going into the smart contract, and then the amount itself, which we have named the token amount that we receive. So this is a sample example of how that function will look like. So this function accepts ETH and token from the user. However, this implementation is incomplete, of course. So these are just snippets of how the DEX is formed. And then another person can come along and add liquidity in a completely different ratio of the reserves, which would massively affect price calculations. So in our cases, we do not want to have those, and that's when slippages come in, and also making sure that we have those slippages, that we always ratio back the prices of these different tokens to a reasonable price. So in any case, after the first person that added the liquidity, who created the costs of the ratios of the different tokens, so when other people come and maybe add more of let me say given token, our pool, our liquidity pool should have the capacity to remain stable. Though you have more of token B, it should remain in the same ratio. So we add also that in the code that we write to cater for it. So yeah. So any questions up to where we are? Should we continue? So based on what we've covered so far, I think I can give some homework. Tomorrow we are going to be writing a smart contract that implements the Uniswap v1 smart contracts, where we are going to have the exchange of tokens, adding liquidity, all of it written in a smart contract. So my assignment should be, there is this article in a deep dive into automated market maker, for us to go back, read through some of these functions so that we can continue with our foundry. So this is one of the functions that we've written. You can read through the curve, the slippage, and we've been here. So these are some of the additions. Please read through these smart contracts and their actually functions, and know how and why they were implemented, and read through about the liquidity provision, how it's updated and things like that, how the fees are divided, how much Uniswap takes out, Yeah, and then so from there, tomorrow then we can look at, you know, creating the real smart contract, deploying it. Our aim will be the entire process, deploying this smart contract. We shall just go through it, deploy it, and then see it in action. All right, so let me share this article. And central code cohort 2. And I think I've shared it. Otherwise, I'm open for questions, feedback. So far, how is it? And this time, the way we really are handling smart contracts is a bit different, more practical. We are trying to push away the fear. So please, yeah, feedback is highly welcome. Any questions? If there are no questions, let's meet in tomorrow's session. Have a great night.